Hello everyone, very good evening and welcome to the BYJU'S exam prep. This is Sanjay Rathi and we are going to start what very important series for you, that is question from standard textbook. Here we will solve questions from Sadiku. Okay, that is Alexander and Sadiku, Fundamentals of Electrical Circuit, 5th edition, and question series network chapter 1. First chapter I am going to start, that is what basics. Okay, so very good evening everyone. Now please let me know that everything is fine, sound quality, picture quality, everything is fine. Okay, I think now everything is fine, guys. Now as you know, this book is very important for what all competitive exams, especially for GATE exam. Okay, so just to motivate you how to solve the questions from standard textbook, and we will solve number of questions from all chapters. So just I am going to start with the first chapter, then second, third, daily at 5 p.m. Okay, now guys, this is my introduction. Myself Sanjay Rathi. I am having 23 years of teaching experience and I have trained more than 1 lakh students for these competitive exams. I have qualified and selected for engineering services exam, and that is only because of what? Standard textbook. For all subjects we have some standard textbook. For example, in network, Alexander and Sadiku, Van Valkenburg. For analog, Milman Helkias, and then what Sadran Smith. Similarly for what other subjects, we are having the number of standard textbook, and you have to solve some selected numericals from standard textbook. Okay, then PDF, Shreyans, I am not having the PDF of that. If suppose it is available authentic copy, then I will share with you. Then this is a book, Alexander and Sadiku, that is I am having the hard copy of that. Is it visible everyone? And that is 5th edition, Fundamental of Electrical Circuits. We will start with the chapter 1. Okay, and then chapter 2, chapter 3, all relevant chapter related to your syllabus of GATE exam and engineering services exam. Van Valkenburg is also a good book. Again, if you are going to give the proper response for this series, then definitely I will solve standard selected question from Van Valkenburg also. Okay, especially from what transient and what two-port network. So this is my Telegram channel. If you want the PDF of this session or notes or notification about the exam, notification about the classes, then you can join my Telegram channel, right? Then first question, that is very basic question. Today we will discuss what question related to what charge, current, time, energy calculation. Okay, some students find difficulty how to apply the how to use differentiation or what integration. You will get idea from this particular session, guys. Now this is a very simple one. Everyone try to give me the answer. Again, that is the unsolved numerical from Alexander and Sadiku, right? And that is from the first chapter. If you have book, then okay, then I will solve selected numericals, then try to solve some important numericals. I will give you the assignment also. Okay, that is from the first chapter. And then get the idea about the basics. Now first of all, this question, what is this question here? The current flowing through an element is 4 ampere for 0 t is 1, and that is the 4t square. Okay, normally we are having question on this, find the charge, and they will provide you what graph and you have to integrate it. But here the direct current is given. The current flowing through an element is 4 ampere and then 4t square. Calculate the charge entering the element from 0 to 2 second. Then remember, the charge is given by integral of I dt, 0 to 2. And if you have any initial charge, then this is the 0. Charge at 0. That is the charge at up to particular time. Then second one, what is the current here? That is given by dq by dt. Current is given by dq by dt, guys. Right? Now, then this is the I dt, that is the q0. Then you have to integrate it. When we will integrate, so what is the integration? What is the initial charge given? 0, nothing. then you have to integrate from 0 to 2 seconds. Means first of all you have to integrate from 0 to 1 second. And what is this? 4 dt plus second 1 to 2, what is the formula? 4t square dt. Then this will become 4t, 0 to 1, 4 is common, what is the integration? T cube by 3, 1 to 2. Then this will become 4, 1 minus 0 plus 4 by 3, this is 2, 8 minus 1, that is 7, and then you can find 4 plus 28 by 3, and then this is 12 plus 28, that is nothing but 40 by 3. Very, very, very simple question. That is what? 13.33. Okay, this is a very simple one. Okay, then 13.333 coulomb, that is the 40 by 3 coulomb, that is correct answer. Take care of units, that is the ampere, and that's why the charge will be in coulomb. So this type of basic question. Now next question, that is find the power delivered to the element in example at 5 millisecond if the current remains the same but the voltage is. What is the current remains the same? Because it is a solved example, so just I am giving you the value of the current, guys. The value of the current here in a previous example that is used is 5 cos of 60 pi t. 5 cos of 60 pi t, that is the current. You have to use this current, that is the question from the textbook. 5 cos of 60 pi t, power delivered to the element, an example, t equal to 5 millisecond if the current remains the same but the voltage is, first option is 2 V is equal to 2I volt, means it will become, when we are multiplying, this will become 10 cos of 60 pi t. Then what is the I? This is the, what is the power here? V into I. When we are multiplying these two, V into I, that is, it will become 10 into 5, 50, then cos square 60 pi t. So why I have chosen this formula? Because we are doing the calculation mistake here. T, that is t is given as 5 milliseconds and this is the 60 pi t is given. So normally what we are doing, you have to use your calculator in radian mode. If you are using your calculator in radian mode, then you will get the right answer. Otherwise, you can make what mistake here. So what is the radian? You can convert it into radian. Then it will become P is equal to 50 cos square 60 into pi into what is the 5? This is the 5 millisecond. 5 into 10 raised to power minus 3. Multiply it, mode, radian mode, or if anything is given in radian, then you can, for example, it is the 2 radian, you can convert it into degree, 180 divided by pi, that is 57.3. If the radian is multiplied by the 57.3, then it can be converted into what? Radian. Thank you, Ansul. Just we have started and we will solve all type of questions from standard textbook. That is the first chapter, and that's why. And then we will cover all type of questions. Then this is the first case. Tell me what is the answer here. Everyone use virtual calculator and get the answer. What is the value of P here? What is the value of P? What is the power delivered? Okay. Then if you are getting the 17.27 means it is a right answer. Please check your calculation, right? 27 watt. Calculator should be in radian mode. Now second what? Second is what? If the current remains same but the voltage is, in B option, what is the voltage given? 10 plus 5, 0 to t I dt. Right? And what is the I here? Now if it is multiplied here, then in second part, okay, ten plus 5 I dt. t. Okay, what is I? 5 cos of 60 pi t. What is the V? 10 plus 5 integral 5 cos of 60 pi t dt. That is the integration, right? 5I dt means 5 cos of 60 pi t, 0 to t. This is 0 to t. Now first of all find the V. Then it will become 10 plus this is 25. And what is the integration of this? Integration of the cos is sine 60 pi dt. Upon what? 60 pi. Remember, upon 60 pi. And what is the limit? 0 to t. When we are putting the 0, it will become 0. Then put the t here. Then it will become V is equal to 10 plus 25 by 60 pi sine of 60 pi t. That is the value of the voltage here. Now what is the current here? 5 cos of 60 pi t. Then be careful, V is equal to what? V into I. Then you can multiply it. Then this will become 10 plus 25 upon 60 pi sine of 60 t into what? 5 cos of 60 pi t. Now multiply it. This will become 50 cos of 60 pi t. Then that is, now you can multiply it and then you can find the value here, guys. Okay. Then sine 60 pi t cos 65 t, you can write the sine of 2 theta, that is what? 1 by 2 sine of 2 theta, or otherwise you can put the value and then you can find. Again it is in radian mode, but simple, don't worry, and simply you can solve it, right? Very simple, but it depends upon your calculation, guys. Do proper calculation. First of all find the voltage, then multiply it with the current, and then you will get the power. That is called instantaneous power. Exactly t equal to 5 millisecond means 10 to the power minus 3 second. T here 5 into 10 raised to the power minus 3. Calculator should be in radian mode. Find the values and you will get 29.7. That is 29.7 watt. Again, very easy question. That is called instantaneous power at particular instant. That is 5 into 10 raised to the power minus 3 time second. Okay. Now this type of questions, first of all, how we can calculate them? Because in steady state analysis of sinusoidal signal, we have to calculate what? Instantaneous power. So what is the meaning of the instantaneous power? At particular time, what will be the power? So in this way we can solve. Okay. Then next one, this is the check your answer. 29.7 you are getting, yes or no. Then quickly give me the answer for this question. This one. Home appliances. Question based on what? Home appliances, or what? Battery, or what? Sharpener. Normally we are getting this type of questions. Then a stove element draws 15 ampere when connected to a 240 volt line. 240 volt line. How long does it take to consume 180 kilojoule? Right? How long it will take to consume 180 kilojoule? Now what is energy? Power into time. Power into what? Time. Now what is the answer, guys? Everyone. अरे ये तो एकदम बेसिक क्वेश्चन है भाई, सबके सब जल्दी जल्दी बताते जाइए बस. And in next chapter we will in the second chapter is what? From Sadiku we will discuss question from basic laws, and basic law means KCL and KVL. Okay, complete KCL, KVL, mesh analysis. After that analysis, to all questions on KCL and KVL, so that you will get the command over that topic, KCL and KVL, Kirchhoff's current law and Kirchhoff's voltage law. Now tell me, what is the power? VI. What is the current here? 15 ampere. And what is the voltage? 240. So very, very simple. Energy 180 kilojoule. This is given 180 kilojoule into 10 raised to power 3. 240 into 15 into time. What is last? How long does it take? So what is the time you have to calculate? So what is the T is equal to? Okay, very simple one. So how much second? 50 seconds you are getting, everyone? Yes. The calculation without calculator you can also solve this, right? And okay then, 50 second nearly equal to, okay, 6 3 4 3 by 4 and this is 3000 divided by 60. 50 second. 50 second is the answer for this question. Take care of unit only. Okay then, next one. Next question. Then next question from the first chapter. Now guys, this is a very important one based on what one theorem. What is the name of that theorem? Tell me in comments box. Compute the power absorbed or supplied by each component of the circuit in figure. Power absorbed and delivered by. Okay. Now here number of elements 1, 2, 3, 4, all type of elements are here, right? This is any element. We have no idea whether it is a resistor, inductor or capacitor. What is the voltage across it? 5 volt. And what is the current through this? 9 ampere. This is a voltage source. This is a current controlled voltage source. This is again any element which has the element 3 volt. Current is given, that is 0.6 I, but I is given here 5 ampere. Then what is the P1, what is the P2, what is the P3 and what is the P4? Okay, that is based on, yes, Tellegen's theorem. Good. That is what? Tellegen's theorem. Now, remember, if this is any element, this is plus, this is minus. If the current enter through the plus, leave the minus, then the power is positive. Current enter through the plus, leave the minus, or we are getting the power positive, then this is called power absorbed by this element. Power absorbed or dissipated. If it is resistor, then it is called dissipated, or if it is a inductor or capacitor, because energy will store, and that's why we are using the word absorb, right? This is the absorbed by that particular element V into I. Current enter through the plus, leave the minus. But at the same time, if the current enter through the minus, leave the plus, this is I and this is V, then the power is given by minus VI. Negative. Negative means delivered, power delivered. So in our objective, what they are saying, that what is the value? So sometimes we have to give the minus 50 or plus 50, or otherwise we have to mention 50 watt delivered, 50 watt absorbed. It is 50 watt positive means it is absorbed, 50 watt negative means it is delivered. Okay, this type of answer we have to mention. Now tell me, what is the answer? What is the power consumed by this element? Then you can say this enter through the minus, leave the plus. P1 is equal to minus 5 into 9, that is the minus 45. Minus 45 watt is delivered by this element. Now this is actually, this is the battery, but battery can also consume the power. Current enter through the plus, leaving the minus. 9 into 2, that is the 18 watt, that is absorbed by that. This is positive 18 watt. Then it is a dependent source, and what is the value of I? 5. 5 into 6, that is the 30, and 3, it will become 3 ampere, 3 volt. Okay, current enter through the plus, leaving the minus. So what is the P3 here? P3 will become 4 into 3, that is 12 watt. Again, it is absorbed by this element. Again, dependent source will absorb the power. Then this is the 5 ampere. When this is the 5 ampere, 5 ampere will enter through the plus, leave the minus. 5 into 3, what is the P4? 5 into 3, that is a 15 watt. Again, that is absorbed by that fourth element. This is absorbed, this is absorbed. Now this element will deliver the power. This element will deliver the power and all other element will absorb the power. So what is the summation of the power? That is called I is equal to 1 to I is equal to 4. This is the Pi. What is the summation of the power? P1 plus P2 plus P3 plus P4. Then this is minus 45 plus 18 plus 12 plus 15. This is 18 plus 12, 30 plus 15, 45. Minus 45 power delivered, 45 watt absorbed. What is the total power? 0. And Tellegen's theorem is verified. Tellegen's theorem. It doesn't matter whether it is a linear or a non-linear element, lumped parameter or distributed. For every case, what will happen? The power delivered is equal to what? Power absorbed. Active element or passive elements, linear or non-linear, then this theorem should be satisfied. That is, the power delivered is equal to power absorbed, or summation of the power should be equal to what? 0. So it is verified in this particular question, and we have used this concept. When current enter through the minus, leave the plus, then you have to use the minus sign. When current enter through the plus, leave the minus, then you have to use the plus sign. It is power delivered, it is power absorbed. Okay, any doubt then you can ask. This is delivered, this is absorbed, this is absorbed, this is absorbed. Okay, and total summation is what? 0. Now next one, next question. So super node, tomorrow we will use that. What? First of all, we will get the command over KCL and KVL. Various type of question we will solve on the base KCL and KVL, so that it will become 2 plus 2 is equal to 4. Easy. इतना इजी बना लो कि आप देखते ही आपको समझ में आ जाए क्या करना है. एंड देन व्हाट वी विल एंटर इनटू मेश एनालिसिस एंड नोडल एनालिसिस, सुपर नोडल एनालिसिस, सुपर मेश एनालिसिस. ओके, वन बाय वन वी विल डिस्कस ऑल टाइप ऑफ क्वेश्चंस. देन नेक्स्ट वन, this is important information for you guys. You can participate in national scholarship test, take a step towards success in GATE exam and get up to 90% off on our programs. Please note the date on 22nd, means this coming Sunday. Window will be open from 9 AM to 9 PM for 12 hours. कभी भी जहां भी आपको टाइम मिले ये टेस्ट जरूर दीजिए और कोर्स ज्वाइन कर सकते हैं आप. एंड दिस इज, और अगर आपको और डिटेल आइडिया चाहिए, नो द राइट टाइम टू प्रिपेयर फॉर गेट 2025. सपोज यू वांट टू स्टार्ट योर प्रिपरेशन फॉर गेट 2025, then what is the right time? That is given by Dheeraj Sardana sir. It is a live interactive workshop on 18th of October. Please note the time, note the day. That is the 7:30 PM, 18th of October. You can register here for this. Okay, to go through the description you will get the link there. Then next one, find the charge QT flowing through a device if the current is. Now guys, what to sometimes we have to find the voltage across the capacitor. So we are using the integration, but normally we are doing what silly mistakes when we are solving question based on what inductor or question based on what capacitor. So how we can avoid this type of mistake? Please try to solve this question. Then find the charge flowing through a device if the current is. For example, in this equation, initial charge is given as what? 1 coulomb. And what is the current? 3 ampere. Here the initial charge is given as what? 0. Here the initial charge is given as 2 microcoulomb. In every case initial charge is given. Here a very simple current, constant current. Here is the current is the function of time. Here is the current is the sinusoidal current. Then in every case what will be the value of the charge here? We have to find. There are 3 questions. A, B and what? C. Then in the first question, always remember, if you want to find the charge, then integration from 0 to t it dt plus initial charge. That is the equation. That is 0 to t means flowing through a device's current is given, right? And then just we have to find the equation, general equation. So what is the general equation? Here, this is a constant current 3 dt plus what? Initial current 1. Initial current is 1 coulomb. Then it will become what? 3t plus 1. So that is 3t plus 1. And that is the answer for this question. Coulomb. Because it is in coulomb and that's why it will remain in coulomb. This is in ampere. 3 coulomb. 3t plus 1. This is the general formula for this one. Okay. Then sometimes they can say plot it. So if suppose it is a, we have to plot, then guys, this type of shape for the first question. What is the initial current? 3. And that's why the curve will start from this portion. This is the value. And what is the initial? 1. This is the coulomb. That is the time. That is the time. And what is the slope of this line? 3. So always remember what is the line? Y is equal to mx plus c. So here y is q. M is the slope 3t plus 1. What is the intersection? C. That is 1. And that is the line. This is the charge will follow this line. Okay. Now you can find the value at any particular time. The slope is constant, that is 3. This is for the first question. Now second question, 2t plus 5 milliampere, and what is the initial charge? 0. Now you have to integrate it, 2t plus 5 milliampere. Then what is the charge? Integration from 0 to 2, 2t plus 5 dt. And what is the initial charge? 0. Initial charge is 0. Then play with. This is the 2t plus 5. Integrate it. So you will get 2t square by 3 plus 5t 0 to t. And what is the initial current? 0. Then when we are putting that as a 0, it will become easy. That is the value. You can, and that is what is the unit here? Milliampere. Milliampere. Take care of what? Unit only. Then third one, very very simple integration. Now very simple integration. Then third one, 20 cos of 10t plus pi by 6. Please find this value. Everyone try to solve this question. Third one, 20 cos of 10t plus pi by 6. Cos of 10t plus pi by 6. Pi by 6 means 30. 180 divided by 6, 30 microampere. And what is the initial charge? It is given 2 microcoulomb. Now, then if you want to find the charge, integrate it. Right, and that is the initial charge. This is the initial charge. Okay, then when I am going to integrate it, you will get, everyone give me the answer. What is the answer? General term 20, it is a common, and what is the integration of this? Sine of 10t plus pi by 6 upon 10. This is the 10 means upon 10. And what is the limit here? Limit is from 0 to t. Plus what is the initial current? 2 microcoulomb. Now put the value of t, that is 2. When we are putting the t, so it will become sine of 10t plus pi by 6 minus, put 0 here, sine of pi by 6. What is the sine of pi by 6? that is sine of 30. That is sine of 30 is 1 by 2. Then multiply it plus 2. 1 by 2 multiplied by 2, it is what? General answer you will get 2 sine of 10t plus pi by 6 minus 1 plus 2. That is 1. And what is the general answer for the charge? Plus 1. And that is the answer. Okay. Subhajit, what is your doubt, guys? What you are asking? Which subject? So one student have given 2 1 sine of 10 plus 30. Right, Kumar, what is this? 10t plus 30, that is the answer for this question, okay? 2 sine of 10 pi t plus 30 plus 1. This is the initial charge and that is in what? Unit, always remember that is in microcoulomb. Why it is in microcoulomb? Because the current is given in microampere. Current is given in microampere. Okay. Yes, it is a problem solving session, Subhajit. Just we have started solving the question from standard textbook, Sadiku. I have started from the basic, okay, first chapter. If you have the 5th edition of Sadiku, you can also solve question with me. Okay, तो यहाँ पर आ जाओ. बस मैं थोड़े थोड़े selected numerical solve कर रहा हूँ because it is a very basic subject. Second again KCL, KVL, then what analysis, then theorems. We will solve all important questions from the theorems, important questions from two-port, transient, okay. Then now next one, this is the answer for the third one. Already we have solved 20 cos of this. Now next one, this one. Sometimes we are getting graph, 2 marks question in GATE examination. Okay, what will be the answer? Again from the textbook. The current through an element is shown in the figure. This is a current 10, 5. Determine the total charge that passed through the element at t equal to 1 second, t equal to 3 seconds and t equal to what? 5 seconds. What is the total charge passed through the element at t equal to 1 second, then what? 3 seconds, then what? Up to 5 seconds. Then there are 2 ways to solve this question. I will discuss both the ways. First of all, find the equation of the current, or integration means what? Area of the curve. Right, integration means what? Area under the curve. So you can find the area under the curve means, if you want to solve this question, there are 2 ways. First, area under the curve. If suppose you want to find the charge, what is the integration means? I dt, 0 to 1. That is the charge. It means this is area under the curve, means up to this point. What is the area? So this is a rectangle. So 10 into 1. So 10 into 1, what is the area? Or you can also integrate it. 10, because the current is 10 dt. And you will get 10 into 1. That is the 10 coulomb. That is the 10 coulomb. Now, for this one, up to what? What is the next question? Up to 3 seconds. What will be the answer, everyone? Okay, this is the area. Please calculate it. That is so easy. Everyone knows that is we have to calculate the area. But try to calculate it and give me the answer. Normally, we are doing silly mistake in this type of questions. So, tell me what is the area. Now, this is the 10 coulomb. Up to 3 seconds we have to find. Then you can divide into 3 areas. A1, A2 and what? A3. A1, A2 and what? A3. Then A1 already we have calculated 10 coulomb. Then what is the A2? A2 is a trapezoidal like this. Okay. Then this is the side A. this is the side B, and let this is the perpendicular distance H. Then the area of this is half of A plus B, just opposite side, and what is the perpendicular distance H? That will give you the area. So similarly, what is this side AA? It is what, 10. What is this? 5. This is 5. And what is the perpendicular distance? 1. This is called H. So this area will become 1 by 2, A 10, B 5, and what is this? 1. So 10 plus 5, 15 divided by 2, that is the 15 divided by 2. So area A2, 7.5. 7.5. You are giving the Q2 is equal to 25. I will check your answer. Everyone give me the answer. What is that Q2? Now, third A3. What is the area of this? This is the 5, and what is this one? This height is 5 and this is 1. So what is A3? A3 is 5 into 1, that is what, 5 coulomb. Now please add all this. So what is the Q2? Up to 3 coulomb. What is the answer? 10 plus 7.5 plus 5, and you will get 22.5 coulomb, and that is the answer. That is the answer, 22.5. You are giving the Harshvardhan, you are taking up to which point? I have asked what is the question. First of all, read question carefully. Up to 3 seconds. So when we are calculating up to 3 seconds, I am getting 22.5. 22.5 is the answer for this question. Okay. Okay then. Now, yes, you have given the right answer, King. Okay, that is typographical error. Sometimes we are doing typographical error. Sometimes what we are doing, just calculation mistake. These all are what? Silly mistakes. And that's why I have taken this chapter. Okay, next one. Up to 5 seconds, what will be the answer? Now up to 5 seconds. So already we have calculated the area up to 3, 22.5. Then you have to calculate area of this portion only. What is the area of this portion? So area, we can again divide it into 2 parts. This is this one. Now, this is a triangle. This is a square, and that is the triangle A4, A5. Because already we have A1, A2, A3. Then what is the A4? 5 into 1, 5. A5, triangle, half of base. What is the base? 1. What is the height? 5. And that will become 2.5, and this is 5. So already up to this point, what was the area? 22.5. A1 plus A2 plus A3 plus A4 plus A5. So 22.5 plus 5 plus 2.5, and that is nothing but 30 coulomb. 30 coulomb is the answer for this question. Right? Okay. Then watch this. No, just we are saying that it is not charging or discharging. When it is the current is negative, then we can say discharging. Right? Then we can say discharging. The slope is negative. Slope negative means what? Just we are reducing the current, not the charge. Right? Slope is negative. When the current is negative, we are changing the direction of the current. Current for throughout this journey from 1 to 2, what about the current? Current is positive, but only it is decreasing from what? 10 to 5. The slope is negative only. Okay, and that's why it will charge. And that every time from A1 to A2 to A3 to A4, A5, every time the charge will increase. Suppose the area is below this 0 line, then the current is negative, then we have to subtract that area. Okay, so we have to add all this. Now, okay, tell me, what is the current from this point to this point? What is the equation of the current? What is the equation of the current? Just find this question, because this is very important one. How we can find the equation of the current here? Now watch this. For example, if you want to write the current at all the time, then what is the current at all time? First of all, from 0 to 1, it is what? 10. 0 to 1, it is 10 ampere. Now what is the current from this point to this point? Again from 2 to 4 you can say, sir, 5. 2 to 4. It is 5. Now what is the current from 4 to 5 and 1 to 2? Then if you want to write this equation, then what is the equation of the line? Y is equal to mx plus c. Similarly, you have to find I is equal to what is the slope into time plus interception. Now watch this. It will reduce by 5 value, by 5 unit in one step. So what is the slope? Change minus the change divided by that. So what is the change? 5. And what is the step? 1 step. That's why the slope is minus 5. First of all, find the slope. And what is the slope? New students, watch this. Slope is given by y2 minus I1 upon x2 minus x1. So what is the y2? 5 minus 10 upon x2, 2 minus 1. That is, you will get the slope minus 5. You will get the slope minus 5. And now, if it is minus 5, what is the equation? Minus 5t plus c. How you can find the intersection? What is the c value of the c? Y-axis. Now, when the t equal to 2, what is the value of the I? 5. You can put here. At t equal to 2, value of the I is 5. Now, this is 5 is equal to minus 5 into 2 plus c. What is the value of the c? You can say 5 plus 10, that is the 15. The value of the c is 15 here, and that's why the equation of this line is, what is the slope here? Minus 5t plus 15. That is 1 is less than t is less than what? 2. In this way you can find the equation minus 5t plus 15. How many students have given the answer? No, you have not given the answer. So what is just take it just like a challenge, guys. Just challenge. What is the equation? Just quickly try to give me the answer. In this way we can save our time in exam. How quickly we can find the equation here, right? So this is the minus 5t plus 15. Similarly, now I am giving you the very quick response for this. For example, here, this is in one step it will reduce by what? Minus 5. So this is the 10. Minus 5 is the slope. So what is this value? 10. What is this value? 5. And if it is increased by one step, it will reach to what? 0. But suppose I am moving in the opposite direction, it will increase by what? 5. So I am moving by one step in opposite direction, then it will reach to what? 15. Directly you can say what is the interception at this point? 15. Then what is the equation? I is equal to mx. What is the slope? Minus 5t. And what is the interception? 15. Directly you can write within 10 seconds. Within 10 seconds you can write for this one. Similarly, watch this. In one step it will reduce by the 5. In one step it will reduce by the 5. So what is the slope? Minus 5. Now, what is the c? At this point the value is 5. At this point value will be 10 because we are reducing. At this point value will be 15. At this point value will be 20. And at this point value will be what? 25. So what is the interception? 25. Directly you can write what is the slope? Minus 5t plus 25. And that is the answer. And you can verify it. Exactly at t equal to 5, the value should be 0. Minus, you can put the minus 5 into 5 plus 25. What is the answer? 0. Means this is the equation of the current for duration 4 to 5. That is it. So directly I have said, no, directly. In one step this is 5, then at this point this is 10, at this point 15, then at this point 20, and at 0 it will become 25. To move like this. So 25. So finally you got all the equations at all the range. Then this is minus 5 t plus 25. 4 is less than t is less than what? 5. Okay. Now You can also find the equation, or you can also find the charge by integrating this, but it is very easy to find area as compared to first of all get the equation, then integrate it, and then again. But in some questions it is not possible to find the area, then you can find the equation and you can integrate in the range, or if directly the equation is given, then directly you can integrate it. Okay, this is 25. Now next question. 2 marks question in GATE exam, different type of diagram. Now this one. Quickly, now rapid round guys, everyone tell me. A rechargeable flashlight battery is capable of delivering 90 milliampere for about 12 hours. Rechargeable flashlight battery is capable of delivering 90 milliampere for about 12 hours. How much charge can it release at that rate? If its terminal voltage is 1.5 volt, how much energy can the battery can deliver? Terminal voltage it is given, and how much battery it can deliver. Okay, King, you have given the right answer. Now, rechargeable flashlight battery capable of delivering 90 milliampere. And for how many hours? About 12 hours. Time is 12 hours. 12 hours means in 1 hour we are having 3600 seconds. It will become 12 into 60 into what? 60. That is what? Seconds. That is seconds. Now, how much charge? Because the charge is what? Current into time, but time should be in second. 90 into 10 raised to power minus 3 into 12 into 60 into 60. Then multiply it and you can find the value of charge here. Now, what is given? If its terminal voltage is 1.5 volt, if its terminal voltage is 1.5 volt, that is constant voltage, then what will be the energy delivered? Then energy delivered is given by energy is what? Charge into voltage, QV. Charge into what? Voltage, that is what? QV. Actually energy is what? Power into time. What is the power? Vi into T. So what is the IT? Current into time, that is the charge. This is the QV. We are using this formula QV, charge. Then now you can find, first of all find the Q, and then voltage is given 1.5 volt. Please everyone, please multiply it and you will get the answer for this question. Okay, fast calculation, you have to use virtual calculator for this. 3.3888 coulomb. I think this is the answer. 3.88 kilo coulomb. Right, now this type of questions. This is important information for you guys. Again, GATE 2024 electronics engineer all India open mock test schedule for that, right? And this is from the 14th of October to 20th of October. Already it is started. You can participate in this because it is up to 20th October for computer science, for electronics, civil, mechanical, and what? Electrical branch, for means all 5 branches, all India open mega mock test. And you can attempt now for this, and that is the schedule for what? Electronics engineer, because I am from electronics branch. Similarly, you can get the schedule for what? Electrical or computer science or other branches. Okay, participate in. और आपको बेनिफिट भी है, अगर आप अच्छे से परफॉर्म करते हैं, आपके नंबर अच्छे आते हैं, तो आपके लिए रिवॉर्ड्स भी है. यू कैन ज्वाइन देयर. और जहां भी अभी फ्री टेस्ट हो रहा है, तो फ्री टेस्ट में पार्टिसिपेट जरूर कीजिए. आपको पोटेंशियल भी समझ में आएगा कि कितने पोटेंशियल में हो आप. ये है इंपॉर्टेंट इंफॉर्मेशन फॉर यू. देन नाउ दिस इज द क्वेश्चन. द करंट एंटरिंग द पॉजिटिव टर्मिनल ऑफ डिवाइस इज 6 e raised to power minus 2t and the voltage across the device is 10 di by dt. Find the charge delivered to the device between 0 to 2 seconds. Second, calculate the power absorbed. Third, determine the energy absorbed in 3 seconds. So new students, I have solved number of questions, and that's why this is the assignment for you. Okay, and get the answer and post this answer on my Telegram channel, that is Electronics by Sanjay Rathi. I will share your name on this same session. 5 PM सेशन, ओके। कि ये बच्चों ने इन्होंने सॉल्व किया, और आपके अगर आप आंसर डिटेल में पोस्ट करना चाहते हो देन अगेन यू कैन पोस्ट योर आंसर ऑल्सो, ताकि आपके आंसर्स को भी मैं दिखाऊं। दैट इज द अप्रोच ऑफ पर्टिकुलर स्टूडेंट, ओके। ऑल कोई भी आप मुझे भेज दीजिए टेलीग्राम चैनल पे, वहां से मैं डाउनलोड करके आपको ये आपको आंसर मैं यहां पर पोस्ट कर दूंगा। तो कैसे आप सॉल्व कर रहे हो, क्या है आपकी अप्रोच, कितने शॉर्ट तरीके से आप सॉल्व कर सकते हो, जैसा आपको बनाना है बनाइए, राइट आंसर दीजिएगा। अब देखते हैं जरा नेक्स्ट जो क्वेश्चन है। देखो टेलीगन्स थ्योरम में कई बार ऐसे क्वेश्चंस आ सकते हैं, जैसे मैंने आपको पहले भी बताया, फिगर शोज अ सर्किट विथ 5 एलिमेंट्स, P1 is given, P2 is given, P4 is given, P5 is given, calculate the power P3 received or delivered by the element. These are the questions from what unsolved practice questions from Sadiku chapter 1. तो वहां बहुत सारे क्वेश्चंस दिए हुए हैं, उसमें से मैंने कुछ सेलेक्टेड क्वेश्चंस सॉल्व किए हैं, और आप भी कर सकते हैं ऑड वन। व्हाई ऑड वन? बिकॉज आंसर फॉर ऑड क्वेश्चंस आर गिवन। तो पहले आप ऑड क्वेश्चन सॉल्व कीजिए, देन अगर आपको टाइम मिल रहा है तो इवन नंबर ऑफ क्वेश्चन सॉल्व कीजिए, ओके। देन टेल मी, figure shows a circuit with 5 elements, P1 is given, P2 is given, P4, P5, calculate the power P3 received or delivered by the element. Then according to Tellegen's theorem, I is equal to 1 to n, what is this? 0. So P1 plus P2 plus P3 plus P4 plus P5 is equal to what? 0. Then directly you can write this is the minus 205. Everyone, what is the P3? Tell me. What is the P2 here? 60. What is the P3 here? We have to find the P3. 45, P4, P5, it is 30. Is equal to 0. Then what is the P3 here? 205. This is minus 60 plus 30, 90, 135. 135, and you will get the 70 watt. And 70 watt is absorbed, because it is positive value, means it is absorbed by this element. Absorbed by this element, okay. This is the very, very simple question based on Tellegen's theorem. Then next one, a constant current of 3 ampere for 4 hours is required to charge an automotive battery. If the terminal voltage is 10 plus T by 2, where T is in hours, how much charge is transported as a result of charging? How much charge? Okay, number of questions we have solved on this, right? But just try to understand. अब इसकी बात हो रही है बार बार, battery charging, we are talking about the battery charging and so on, and that's why we have number of practical question in chapter number 1. Then constant, how much charge is transported as a result of charging? Current of 3 ampere for 4 hours, you can find the charge. If the terminal voltage is this one, then if you want to find the charge only, then this is a very, very simple question. Current into time. Time should be in what? Seconds, and that will give you the answer, okay. Please find the value. And then you can find. Kilo coulomb. 43 kilo coulomb, guys, okay. So this is the amount of charge. Now, to which are relevant already I have given. Then second one, last question. In a household, watch this, in a household, 120 watt personal computer PC, that is the question number 1.31 again from Sadiku. 120 watt personal computer is run for 4 hours per day, while a 60 watt bulb runs for 8 hours per day. If the utility company charges $0.12 kilowatt per hour, right? kWh, this is the unit of, not per hour, kWh means what? This is the unit here, 1 unit, kilowatt hour. Then calculate how much the household pay per year on the PC and the bulb only. तो देखो दिस इज द क्वेश्चन फ्रॉम यूएसए, बट अगर ये इंडिया में क्वेश्चन है तो रुपीज में आएगा, वो कोई प्रॉब्लम नहीं है। रुपीज आप डॉलर को रुपीज में कन्वर्ट करके आप बिल निकाल लीजिए, राइट, तो आपको पता चल जाएगा कितना बिल आ रहा है। लेकिन यहां पर आएगा, क्या आएगा आंसर बोलिए। अब इन अ हाउस होल्ड 120 watt पर्सनल कंप्यूटर इज रन फॉर 4 hours पर डे, you can directly find this in kilowatt hour. No need to convert it into what seconds. So what is the what 120 into 4 into what 365 days. Find the value. This is watt hour. This is watt hour. You will get this value. Then similarly, this is for PC. Then for bulb, it will become 68 per day, and how many days? 365 days. Okay, 365 days. Then multiply it, again you will get watt hour. Then add these two, divide it by the 1000, you will get kilowatt hour. And then finally, once you will get the unit kilowatt hour, then it should be multiplied by 0.12. Then you can find the value. Okay, so what is the unit here? Kilowatt hour. Can you do this question, everyone? No need to convert it into what? Seconds and so on. Directly you can multiply and directly you can find here. That is the unit. Okay. अब आपको यहां से अंदाज लग जाएगा कि आप एक पीसी या बल्ब यूज कर रहे हैं तो आपने साल भर में कितना एनर्जी कंज्यूम की है। ओके, देन तो ये है क्वेश्चन। टेल मी व्हाट इज द आंसर फॉर दिस वन। व्हाट इज द आंसर फॉर दिस पर्टिकुलर क्वेश्चन? ओके, जस्ट आई हैव गिवन यू द हिंट फॉर एवरी क्वेश्चन एट द एंड फॉर ऑड नंबर ऑफ क्वेश्चंस आंसर इज गिवन. If you have the hard copy of that, then for every question, for example, that is the question number 1.31, means on page number appendix D 821, the answer is given 42.05 $42.05, means answer is given 1.31, and then yes, bilkul that is correct one, 42.05. You can verify your answer then. Okay, I think now any feedback regarding this session? So that is a session, first session on what? Basics. So guys, you can also install what that is BYJU'S exam prep from Google Play Store and try to give the mock test. Here you will get the leaderboard. So how many students participated in what test and what is your rank, what is your score. Everything you will get about the mock test here. Then this is a crash course for GATE 2024. If you want to start your preparation for GATE 2024, then you can start your journey with us. This is for electronics and that is for electrical. Live classes are available, recorded lectures are also available, study material, practice quizzes, mock tests. For more detail, you can call at this number, right? This is my Telegram channel. I will upload the PDF of this session. Electronics by Sanjay Rathi. For PDF of this session. आपने किसी ने कहा सर बुक्स का PDF अवेलेबल है, अगर ऑथेंटिक कॉपी है तो मिलेगी, नहीं तो आप लोग सर्च कर सकते, लेकिन अगर आपके पास हार्ड कॉपी है देन यू कैन सॉल्व द क्वेश्चन फ्रॉम दैट. हार्ड कॉपी से यह है कि स्क्रीन टाइम आपका बचेगा और आप ज्यादा बुक्स में और अपनी रफ कॉपी स्क्रिबल पैड में क्वेश्चन बना पाओगे. ओके, so what is your feedback? Season sir, please complete this series for all topics. Okay, next topic on daily at 5 p.m. daily at what? 5 p.m. just once the question from Sadiku over, then we will start from what? Solving question from Van Valkenburg also. Okay then, thank you. You are on BYJU'S exam prep. Like the session, share the link of this session and subscribe our channel. Thank you.